This video shows an example of color histogram-based blob tracking using fused point cloud data generated by 3 Kinect One sensors. To initialize for the first time, you need to select the region of interest from the top-down image. The first example is plotting the black and white image mask, which shows in white the pixels that have colors that fall within the histograms at a level of confidence. This figure shows data based purely upon the RGB image converted to HSI then filtered. This is fast, but at this stage there's noise since some pixels are mistakenly detected as falling within the histogram and are shown up as white dots. This view is stopped and the tracker is started. In this case, for the first detection frame, the image is processed to remove the noise and identify blobs, then the centroids are identified. After these centroids are simply tracked by looking at the nearby regions to where the centroid was last seen, using the fused data this time. A common filter is not used in this example. The GPU is used to more quickly find candidate volumes of space, and finally a decision is made as to whether the centroids have been found or lost. If found, it will continue looking for the objects in subsequent frames. If lost, the detection process is repeated. It is also possible to select multiple histograms. In this example there are 2, such as the purple and the yellow. Once again the image mask is shown, except this time we can change between any number of histograms. At this stage the colored objects are not really detected or tracked and no centroid is identified. The color space is changed to HSI, then the histogram blobs from the first 2 channels are saved to file so it can be used and loaded in future. Matlab blob tracking connects to a ROS topic that publishes the fused and transformed point cloud. Notice how the purple is marked with a red star and the yellow block is marked with a green star. These star colors are arbitrary and are not attempts to match the object color. Notice also how the purple objects are different enough that it detects the correct one and not the other one on the scene. The centroid locations are being published back to ROS and so can be shown in RViz. The orientation is not detected here, but the objects are detected in 3D. Even if blocks are stacked, they can still be detected because of the 2 cameras that are looking at the scene from the side.